hopefully this is coming back to you. It's basic junior high science stuff, but and understand on the screen it says protons and neutrons have about the same mass. They're not exact. Obviously, there's differences. A chemistry teacher would probably cringe at that statement, but when you draw them, you'll notice we draw them pretty much. You can see them here about the same size. That way, it represents that. And that protons have a positive charge, neutrons have no charge, they're neutral, and obviously electrons have a negative charge. And here's the deal. This is an old saying in chemistry, and we talk about a lot. Unlike charges attract, like charges repel. And you see that very, very well in the nucleus of an atom. There is that attraction between the electron, which is negative, and the proton, which is positive. And that's what keeps those electrons in orbit. So you'll hear me talk about this when we go over photosynthesis and respiration. How does a plant trap energy from sunlight? That sunlight will knock these electrons around and energize them. And that's how we trap sunlight, and plants can grow and do their thing. So this is why you got to have some basic understanding of exactly, what is a proton, what is a neutron, how they work, what's an electron. That's really important to understanding biology concepts later. There are strong forces. I'm not going to get into those right now that bond those protons and neutrons. That's more of a chemistry topic, but they are in the nucleus. An electron is extremely small. Look at that fraction. That's a fraction 1,840th of the mass of a proton. It's insane how small that is. So, we discovered electrons a long time ago, and then later on we discovered neutrons, and then finally protons. So it's been a progression. We now understand exactly what they do. Okay, now for you to understand, we're going to take a little chemistry quiz coming up here on Monday over some of these basic stuff. So over the weekend here, kind of look this stuff over, do that worksheet that's on there, the e-learning and that kind of thing. That'll help you. Electrons are constantly in motion is what you need to understand. They're attracted to a positively charged nucleus, but they remain outside the nucleus because of their energy and motion. You probably remember that from middle school, kinetic energy and that type of thing. And that attraction, that pull from the protons is what keeps them in these orbits. Now, I don't need you to understand an S, a P, a D. That's chemistry concepts, which orbit, which path they follow. There's different paths they can go. For what you need for this class, I just want you to know that they're kind of held in place by that attraction between the proton and the electron, that positive, negative thing. Now, this is really important. Because atoms have equal numbers of electrons and protons, their positive and negative charges kind of balance out. That's why we say atoms are electrically neutral. So what I have up there is a diagram of a carbon atom. It has 6 protons, 6 electrons. There's an attraction between the two of those, right? And you'll notice that there's 6 electrons and 6 neutrons, or 6 protons and 6 electrons, and that's how they balance each other out. When we do, and you'll notice that from the worksheet, from the e-learning from today, you don't ever mess with the protons and the electron number. Okay, we're going to talk about that in just a second. Neutrons can change. We can add neutrons. And neutrons can be of different number, but protons and electrons are always going to be equal. So if I have an element that has 25, protons, it has 25 electrons. If it has 80 protons, it has 80 electrons. We know those numbers. Okay. Now, where this gets a little bit crazy is in the realm of elements. So, you guys know a periodic table of elements. I'll put one of those up here in a minute. I have one linked on your WebQuest. I have one linked on your exercise you're supposed to do this week with that little chart. Hopefully that made sense to you. An element's a pure substance made entirely of one type of atom. And there's over 100 some elements on the periodic table, but we're not going to worry about most of those. We're mainly worried about the big ones, like you see on the screen. 99% of your body is made up of oxygen, carbon, nitrogen, hydrogen, calcium, and phosphorus, the big 6 we call them. That's what we're going to mainly focus in on. That's in the foods that we eat. That's in the compounds that we break down for digestion. That's in ATP and all kinds of things that we're going to talk about. So we're going to mainly focus on the elements that affect us, living things, because this is a biology class. Now, understand, we try to use symbols that make sense, but they don't always in chemistry. First letter is the easy ones, carbon, C for carbon. We represent these by symbols. Hydrogen's an H, but then we get weird ones like sodium's in A, mercury's Hg, gold's Au. We get some weird things like that, Ag and stuff like that. And some have 3 letters when you get way up there in the 100-some realm. So if you look at a periodic table of elements, let's just put one up here real quick. Give me a second to scroll through here. So that should look familiar. And we got the element, we got atomic number, atomic mass. We have all these things going on in this periodic table. So let me kind of go over that today. This is really important. So when we take our quiz and when you do these worksheets for e-learning and stuff like this, this will help you. So hopefully you'll watch this video if something doesn't make sense. Well, hopefully you watch the video, period. But let's talk about what can mess up these numbers a little bit. So we have these things called isotopes. Let's go up a little bit. Go back to elements. There you go. Up one more slide. So here we go. So let's start with atomic number. The top number on the periodic table. So I got an element in a box, right? And it says carbon, big C. And then there's this 6 up above the C. It might be in the left corner, it might be in the middle, depends on what periodic table you look at. That tells me the number of protons. Good quiz question Monday. So let me say that again. The number of protons is the atomic number, okay? So if carbon has atomic number of 6, not only do I know I have 6 protons, what we do know from the thing I just went over is we also have 6 electrons because they have to balance each other out. So if I know one number, I know the other. Now be careful though, on the quiz, don't put down atomic number is the number of electrons. It is the number of protons, but since I know that number, then I know how many electrons I have, if that makes sense, okay? So as you're filling in those tables on the e-learning and on that assignment I gave you earlier this week, you'll notice that those numbers, the proton column and the electron column are going to be the same, and the atomic number is going to be the same. Those 3 columns always equal. Don't ever mess with those numbers. So on the quiz, on the e-learning, you got to make sure atomic number, proton, electron, they match all the way across, okay? So in this case, atomic number 6, proton number 6, electron number 6, right? Simple. You guys learned that a long time ago. Now, neutrons is where it gets interesting. Protons and electrons are easy. Neutrons, we have this problem. Some elements have different numbers of neutrons, and that makes them different. The example I'm going to use is carbon. Carbon on the periodic table is C6. I just went over that. So it means it has 6 protons, 6 neutrons, 6 electrons. That's what the element on the periodic table has. But I also have carbon-13 and I have carbon-14. Those are called isotopes. One has 7 neutrons, one has 8 neutrons. Okay, now that messes us up when we're looking at these numbers on this chart, like on the quiz or on the e-learning or whatever. So with isotopes, we have to take this in consideration. So let me explain something that's really important, and this will make sense, I think, to you, and it should ring a bell. The total number of protons and neutrons is called the mass number, not to be confused with atomic mass. I hear people and I see websites, I've even had other teachers from other schools say, oh, those mass number and atomic mass are exactly the same thing. Not true, okay? Look at this chart. Mass number is protons plus neutrons. So here I got 12. That's my mass number. This is 13 because I have 7 neutrons. So 7 plus 6 is 13. And carbon-14 has 8 neutrons. So 8 plus 6 is 14. So that's what we call isotopes, okay? Now, look at that. 12 and 13 are non-radioactive. Carbon-14 is radioactive. So what's the deal? When you get extra neutrons, they start to break down and decay, and they give off radiation sometimes. So some of these isotopes, we'll talk about that in the next video, we have to be careful with some of them because they're radioactive or they behave a little bit differently than the other isotopes or the other ones on the periodic table. So kind of be careful with that. Now, here's where it gets confusing. So stay with me. A mass number is protons plus neutrons. What's the deal then when I look on a periodic table and I see these decibels? So we always put at the bottom of a periodic table the atomic mass. Here's the difference. So listen closely. Good quiz question Monday. The atomic mass is the weighted averages of all the isotopes. So we have to go back and we have to take 12, 13, 14. We add up all these isotope numbers. We divide by 3 and we get a decibel. That is atomic mass. Okay? So let me say that again because I want to make sure you guys understand this. Mass number is protons plus neutrons. Atomic mass is the weighted averages of all the isotopes. So you notice maybe on the chart that we did for a homework assignment this week, I asked for mass number. You just add up protons and neutrons on that chart you did. For atomic mass, you got to look up on the periodic table and you will put a decibel number. So depending on what I asked for or what a assignment asked for, that's the difference. So make sure you look at that. If you got questions, let me know. Email me. Let me know because I want you to make sure you get that right on the quiz. All right? Okay, so that's it for today. Just kind of want to get that in. Hopefully you watch it over the weekend. You can fill out the e-learning, and hopefully we'll take that quiz. I'll give you a Google form during your class time, so make sure you log in tomorrow because some of you didn't do very well taking the first test. You got to get on there, log on. I will send you a password, and we'll take the quiz on Monday. All right? Hey, have a good weekend, and we'll put another video on Monday. So we'll see you. Thank you. Bye.